Okay, we're going to show how you should represent oxidation reactions of alcohols, how the exam board want you to do them. Okay, so here we have got ethanol. That's right, ethanol CH3. Oops, Daisy. Right, ethanol. So CH3, CH2OH, and you're going to oxidize it to an aldehyde. Okay, so now an aldehyde, the aldehyde will have this, be like that. The way that the conventional way of showing aldehydes in one line is you write them like that, CHO. I think because if you wrote COH, it would be confusing. You might think it was an alcohol or something. So that's the way you should write it. Now that is an oxidation reaction, and what they want you to do is they want you to represent the oxidation. Represent the oxidizing agent as providing an oxygen atom. And the way you show that is you do an oxygen in a square bracket. That means an oxygen atom with its electrons, okay? I find this a bit unsatisfactory, but it's the way they want you to do it. Okay, so we are going to oxidize the ethanol. So I'm going to put in one of those O's, okay? Now we need to balance it, okay? So let's write down the steps here. So number one, put in the oxygen, okay? The next thing to do is to balance for the hydrogens with water. So what I mean by that is on the left-hand side, you have got 6 hydrogens. You've only got 4 on the right. So that means we need to put an H2O there. And then we need to check its balance for oxygens, okay? Okay, so how many oxygens have we got on the left? We have got 2. We've got 1 there in the alcohol and 1 from the oxidizing agent, and you've got 1 there, so that's all balanced. So that's how you would represent that equation for the oxidation of ethanol to ethanol. Let's do another one. Okay, so get rid of this. Let's have ethanol going to ethanoic acid this time. Okay, so CH3, CH2OH goes to ethanoic acid, which is CH3. CH3, COOH. Okay, so put in the oxygen. Let's put 1 in there. And then balance the waters. Well, we have got 6 on the left. Balance the hydrogens. Got 6 hydrogens on the left and only 4 on the right. So we need an H2O there. The second thing to do is now check. The third thing to do is check the balance. The oxygens are balanced. So we have got 3 oxygens on this side, but we've only got 2 on that side. So I need to put a 2 in front of the oxidizing agent oxygen there. Okay, so that is how you do it. We do 1 more. Let's do ethanol going all the way to ethanol. Well, let's do ethanol going to ethanoic acid. So we've got, let's see, CH3, CHO goes to CH3, COOH. Put an oxygen in there with a bracket around it. Right, first of all, let's balance our hydrogens with water. We've got 4 hydrogens on the left and 4 on the right, so we don't need to do anything there. Check if it's balanced for oxygens. Well, we've got 2 oxygens on that side and 2 oxygens on that side, so it's balanced. We don't need to put any balancing numbers in. Okay, so okay, so that is how they want you to show redox equations in organic chemistry, just rather than satisfactory oxygen in a square bracket. Let's just very quickly, you can stop this video now if you're not interested, but just how would you do it properly? Let's have ethanol going to ethanoic acid. Let's do it in blue. Okay, so we've got ethanol going to, let's say it's ethanoic acid, all the way to ethanoic acid. Right, what do we normally do? We look at the oxygens and we balance with waters, don't we? So we've got 2 oxygens on this side and we've only got 1 on that side, so I need to put in H2O there. Now we need to balance for the hydrogens. Well, I've got 8 hydrogens on that side and I've only got 4 on that side, so that means I'd need to put in what in there? I'd need to put in 4H plus to make that work, and then I'd then need to balance my charges with electrons. So I have got 0 charge on that side, I've got plus 4 on that side, so I need to add 4 E minus on this side, yeah. And you can see, look, the ethanol is losing electrons. It's losing 4 electrons, so it is being oxidized. Oxidation is loss. Well, what was the oxidizing agent? Well, potassium dichromate, and I think we had this in an earlier video. So we've got Cr2O72 minus, that's dichromate, and that's orange, isn't it? It gets reduced to green chromium, so I need to double that. Balance for oxygens, well, I've got 7 on this side and I've got none on this side, so I need 7H2O there. Let's get rid of these numbers. Next thing to do is to balance for hydrogens. I've got 14 on the right and none on the left, so I've got to put 14H plus, so that's why you need sulfuric acid to provide all those protons. Now balance for charges, be careful here, on the left we've got plus 12. 14 minus 2 is 12, and then careful, don't forget it's 2 times 3 plus this, so we've got plus 6 there, so that means we need to put on 6E minus on this side of the equation. Now then what you would do if you wanted to write the full equation, of course you've got your 2 half equations, you would have to combine these 2 half equations, and there's 4 electrons being lost here and 6 being gained here, so what you'd have to do is times this one by 3, wouldn't you? Times that one by 3 and times this one by 2, and your electrons would balance. And then when you wrote the equation, you see that some of these H pluses, you're going to have H pluses on both sides of the equation and some waters on both sides, so any that appear on both sides you cancel them out. Anyway, just to show you there's nothing funny going on there, but you can write a proper equation for it, but we have to use this. As I said, I don't really like it, this idea of an oxygen atom coming from an oxidizing agent, and that's how we, I'm missing a plus out there, that's how we are expected to write these equations for the exam. Okay, we'll stop it there.